Hello everyone, welcome again. So today's lesson will be on the chemical earth, and in this series we're going to look at energy and chemical change. So we're going to look at what energy does to contribute to chemical changes and how they sort of interact with one another. Okay? So in today's lesson we're going to look at what reactions are and what their indications, or how we know that a reaction is happening, rather than just say boiling water, which is not a reaction, it's just a physical change. So what can we notice in a reaction that tells us that a reaction is actually happening? So that's what today's lesson will be focusing on. So indicators. Many reactions release or absorb forms of energy when they occur. Okay, so when a reaction happens, they either emit or receive energy in some form. So here, if we look, a reaction can be sort of identified by the fact that the color is changing, because color changes imply that the electrons are then reconfigured such that they can absorb and emit different forms of energy in terms of different colors. Okay? So there's three major forms of energy that we're interested in. That's light, heat, and electricity. Okay? So light is pretty obvious in, say, a combustion reaction. We can see lots of light, fires and things like that. Heat, same thing. Heat comes out of a combustion reaction as well. Not electricity though. Electricity doesn't happen. In some reactions, electrons can actually be forced around a circuit, and that can actually generate electricity. So those are the three major forms of energy that we're interested in. So light. So here we have an old incandescent light bulb from the Edison days. Very, very inefficient, but you know, sort of an archetype of lighting. Okay, so it emits light, obviously. So light is an electromagnetic energy. Okay, so for those who've studied physics, electromagnetism shouldn't be too much of a stretch for you. But essentially, all it is electric fields and magnetic fields interacting with one another to produce light. Okay. Many reactions, particularly combustion reactions, release light as a form of energy. Okay, so combustion reactions aren't the only ones. A glow stick, for instance, when you mix two chemicals, they'll produce light. Certain insects and other organisms have what we call bioluminescence. So they'll actually mix chemicals in their body to produce light. Okay. The anglerfish, for instance, has that little light bulb thing in front to lure other fish closer so it can consume them. So it produces that light through a chemical reaction. So that's one way that energy can be expended or can be released into the environment through chemical reactions. One of the most famous, probably, light-absorbing reaction is photosynthesis, where carbon dioxide and water are converted to glucose and oxygen. Okay, so that's a very famous. Everyone should know about photosynthesis by now, and it's the biggest one, the most prevalent one in our society as well. So heat. Heat is generated in many reactions as well. So combustion, once again, produces lots of heat. And it is related to the energy of the particles, and thus is a form of energy transfer in chemical mechanisms. Okay, so the temperature is related to the amount of energy that the particles have, and heat transfer helps to change that temperature through different systems. Okay, so that's just what it is. So combustion reactions all release a large amount of heat, because that's what combustion does. And we can actually use that heat for many useful things, like spinning a turbine, or making steam to spin a turbine to make energy, like a coal-fired power plant. Or we can use it to sort of expand a gas and push down on a piston, which makes an engine move, which makes cars move. So we use heat for a lot of very useful things other than just keeping warm. Okay? So heat can be used for lots of things. And the study of heat and its interactions is what we call thermodynamics. Okay? So other times, some reactions like decomposition take in heat to split a chemical into its constituent compounds. So if I was to heat up a carbonate, like calcium carbonate, I could split it up into carbon dioxide and calcium oxide just by applying heat. Okay? So that's when heat is taken up by the system to produce a chemical change. Okay? Lastly, there's electricity. So electricity is the energy related to the flow of charge. Okay, so when we have charges flowing, there's an energy associated with that, and that's what we call electricity. And typically that flow of charge is through the flow of electrons, but sometimes it can be the flow of other charges as well. Positive ions or negative ions as well. So don't be too concerned about what the charges are. Just be aware that electricity is about the flow of charge. Okay? And actually some reactions can generate electricity. They can actually produce this flow of electrons or charges. And batteries are one example of this. Okay, so batteries actually consume chemicals to produce electricity. Okay, and that's probably the only, other than maybe fuel cells. Okay, fuel cells may be the other example of this, but batteries are the most common example where chemicals are consumed and thus electricity is produced. Now, once those chemicals run out, we say the battery is flat, so it no longer produces electricity. Okay. Now, the opposite is if we were to use electricity to make a chemical reaction happen, and we call that electrolysis. So electrolysis reactions absorb chemical or electrical energy to change chemicals to other forms. Okay, so the battery changed chemicals from one form to another to produce electricity, whereas electrolysis takes in electricity to change chemicals from one form to another. Okay, so there's just the reverse processes of the two. Okay. So that concludes today's lesson on reactions and indicators. So we've looked at how we know a reaction is happening and how we know that through the different forms of energy that are emitted, produced, or absorbed. Okay? So we'll move on to the question segment now, and hopefully we can learn some more about these forms of energy and chemical reactions. So describe what is meant by thermal decomposition, and is this an example of a physical or chemical change? So thermal decomposition is when electrons are broken down into smaller components through the application of heat, or sometimes other forms of energy, but mostly through heat. This process is a chemical change, since the starting chemical is changed into several different chemicals by the end of the process. So question 2. Batteries generate electricity by consuming chemicals. So outline how a rechargeable battery works. So how does a rechargeable battery do what it does? Okay. So the chemicals in a battery are consumed to generate electrical energy. So the battery consumes the chemicals and produces electricity. However, once the chemicals have been consumed, no more energy can be produced. Okay? So you can't obviously keep producing energy infinitely. Otherwise, we'd have a solution to the global warming crisis. Okay? So the question is then, what does a rechargeable battery do? So electrical energy can actually be put into the battery to cause the chemicals to return to their original state. So in the battery, the chemicals are still there. They're just in a different form. So if I put in electricity to reverse the process that I did to start with, I can actually change the chemicals back. And by doing that, I can sort of recharge the batteries. And that allows rechargeable batteries to be used repeatedly because the batteries can be discharged, all of the chemicals can be consumed, and then I can turn them back to their original state by putting in more electricity. Okay? So question 3. Glow sticks are a common device that exploits chemistry to produce its effects. Briefly explain the processes involved when using a glow stick. Okay, so I'm sure you've all played with glow sticks at some point. I know I definitely have. And they're fun things, but how do they actually work? So when you use a glow stick, it first needs to be bent and a loud cracking noise is heard. So you have to, crack the glow stick essentially. Now what that does is it releases two chemicals, and when they mix together, they form a new substance which glows, okay, giving the characteristic lighting effects. Okay, so when you crack the glow stick, the two chemicals mix together, and when they mix together, you get that glowing. It's because they react with one another to form light. Okay, so we know a reaction is happening. And that's why the glow sticks eventually stop glowing, because all of the chemicals have reacted together, and so you can't produce any more light because you don't have anything else to produce because there's no more reactions. And that's how a glow stick works. So why are certain types of energy released or absorbed in chemical reactions? So why is energy even needed in these reactions in the first place? Since the chemicals that come out of a reaction and the chemicals that go into a reaction have different amounts of energy, chemical energy, there must be energy release or gain in order to balance that energy. Okay? So let's just look at petrol. Petrol, obviously we can burn. If we burn it, we get a lot of energy out. And carbon dioxide can't burn. Okay, so if you look at when we burn petrol, we try to burn carbon dioxide, nothing happens. So that means that carbon dioxide must have no chemical energy in it because it can't be used for anything, whereas petrol must have a lot of chemical energy in it. Okay? Now the question then becomes, well, how can one suddenly turn into the other? And the easy way to solve that is by looking at the energy that's released in the reaction. So when the petrol burns, it releases a lot of energy, and that energy is part of the chemical energy in the petrol until it finally gets down to the carbon dioxide, which has very little chemical energy. So that's how we balance the two energies. The release or absorption of energy is just a consequence of the conservation of energy concept. So it's just a consequence of the fact that energy needs to be conserved. Okay? Okay. So state one example of a chemical change that involves each of the following energy types. So for heat, so we can extract mercury from mercury oxide through the use of heat. Okay. Light, so decomposition of silver chloride into silver atoms through the use of ultraviolet light. And this is how the old school cameras used to work. Before digital, we had film, and just before the normal film the color film, we had black and white film, which used silver chloride paste, and when light struck it, it would turn black, and that blackness was related to the silver atoms. Okay, so that's one reaction that involves light. And electricity, we can decompose water into hydrogen and oxygen. Okay, so we can use electricity to split hydrogen into water. Split water into hydrogen and oxygen. Okay. So that concludes today's lesson on reactions and their indicators. We've looked at what a reaction is and what indicators come out, and what are the common energy forms that are related to chemical reactions. So I look forward to seeing you at our next lesson.